This is SpaceTime Series 28, Episode 28, for broadcast on the 5th of March 2025. Coming up on SpaceTime, how our solar system's journey through Orion may have altered Earth's climate. Have scientists been wrong all along about why the red planet Mars is red? And NASA's Europa Clipper mission swoops past the red planet on its way to Jupiter. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests that planet Earth's climate may have undergone profound changes 14 million years ago when our solar system migrated through the Orion star-forming region. Located some 1,500 light-years away, the Orion Nebula Messier 42 is still the largest nearby stellar nursery to the Earth, and it's easily visible in the Orion constellation with the unaided eye, looking like a fuzzy middle star in Orion's sword. Now, new research reported in the journal Astronomy and Astrophysics suggests that the solar system traversed the Orion star-forming complex, a component of the Radcliffe Wave galactic structure, about 14 million years ago. Now, the idea is this journey through such a dense region of space could have compressed the heliosphere, the Sun's protective atmospheric bubble around our solar system. In the process, it would have increased the influx of interstellar dust, and that potentially could have influenced Earth's climate, even leaving traces in the planet's geological records. The study's lead author, Ephraim Marconi from the University of Vienna, says the solar system's journey through the Milky Way takes it through varied galactic environments, sort of like a ship sailing through varying conditions at sea. Marconi says the Sun would have encountered a region of higher gas density as it passed through the Radcliffe Wave in the Orion constellation. Using data from the European Space Agency's Gaia mission combined with spectroscopic observations, Marconi and colleagues pinpointed the solar system's passage through the Radcliffe Wave in the Orion region to roughly 14 million years ago. The Radcliffe Wave is a vast thin structure of interconnected star-forming regions, including the renowned Orion complex. Marconi says we passed through the Orion region just as well-known star clusters like NGC 1977, NGC 1980 and NGC 1981 were forming, and the increased dust from this galactic encounter would have had several effects. It may have penetrated the Earth's atmosphere, potentially leaving traces of radioactive elements from supernovae in the geological records. The research indicates the solar system's passage through the Orion region occurred between approximately 18.2 and 11.5 million years ago, with the most likely time being between 14.8 and 12.4 million years ago. Now, this time frame aligns well with the Middle Miocene climate transition. That represented a significant shift from a warm variable climate to a cooler climate, and it led to the establishment of a continental-scale prototype Antarctic ice sheet configuration. While the underlying processes responsible for the Middle Miocene climate transition are not entirely identified, the available reconstructions do suggest that a long-term decrease in atmospheric greenhouse gas carbon dioxide concentrations is the most likely explanation, although with large uncertainties. However, this new study highlights that interstellar dust related to the crossing of the Radcliffe Wave might have impacted Earth's climate as well, and potentially played a role during this climate transition. But the thing is, to alter Earth's climate, the amount of extraterrestrial dust that fell on the Earth would have needed to be much bigger than what the data suggests so far. Marconi says future research will need to explore the significance of its contribution. Now, it's crucial to note that this past climate transition and current climate change which we're going through now are not comparable, since the Middle Miocene climate transition unfolded over timescales of several 100,000 years. Now, in contrast, the current global warming evolution is happening at an unprecedented rate over decades to centuries, and it's due to human activity. This is SpaceTime. Still to come, have scientists been wrong all along about why the red planet Mars is red? And NASA's Europa Clipper mission swoops past the red planet on its way to its encounter with Jupiter. All that and more coming up on SpaceTime. A new study suggests that the red planet's iconic rusty red dust has a much wetter history than previously thought. A new report in the journal Nature Communications claims Mars rusted earlier in the planet's ancient past when liquid water was far more widespread. The new findings are based on a combination of European Space Agency and NASA spacecraft data with new laboratory experiments on replica Martian regolith. Mars is easily identified with the naked eye in the night sky by its prominent red hue. Now, thanks to a fleet of spacecraft that have studied the red planet over the last few decades, we know that this red colour is due to rusted iron minerals in the dust. That is, the iron bound up in Mars's rocks has at some point reacted with liquid water or water and oxygen in the air, which is similar to how rust forms here on Earth. Over billions of years, this rusty material, iron oxide, has been broken down into dust and spread all around the planet by winds, a process which is continuing today. But the thing is, iron oxides come in many different flavours, and the exact chemistry of the Martian dust has been intensely debated because how it formed is a window into the planet's environmental conditions at the time. And of course, closely linked to all that is the question of whether Mars was ever habitable. Scientists know it was once a warm, wet world. But after it lost its magnetic field and consequently its atmosphere, the planet cooled down to become the freeze-dried desert it is today. Previous studies of the iron oxide component of the Martian dust based on spacecraft observations alone didn't find any evidence of water contained within it. Researchers therefore have concluded that this particular type of iron oxide must have been hematite, which forms under dry surface conditions through reaction with the Martian atmosphere over billions of years, and well after the planet's early wet period. However, the new analysis of spacecraft observations in combination with novel laboratory techniques are showing that Mars's red colour is better matched with iron oxides containing water, known as ferrihydrites. Ferrihydrites typically form quickly in the process of cool water, and so must have formed while Mars still had water on its surface. The ferrihydrite has kept its watery signature to the present day, despite being ground down and spread across the planet since its formation. The study's lead author, Adomas Valentinus from Brown University, says the team were trying to recreate a replica of Martian dust in the laboratory using different types of iron oxides. They found ferrihydrite mixed with basalt, a volcanic rock, best fitted the minerals seen by the spacecraft at Mars. Now, the major implication of this is that because ferrihydrite could only have formed when water was still present on the Martian surface, Mars must have rusted far earlier than previously thought. Other studies have also suggested that ferrihydrite might be present in the Martian dust, but Valentinus and colleagues have provided the first comprehensive proof through a unique combination of space mission data and laboratory testing. They created the replica Martian dust using an advanced grinder machine to achieve a realistic dust grain size equivalent to just 1/100th of a human hair. They then analysed their samples using the same techniques as orbiting spacecraft in order to make a direct comparison, finally identifying ferrihydrite as the best match. ESA's Mars Express Orbiter's analysis of the dust's mineralogy helped show that even highly dusty regions of the red planet contain water-rich materials. And thanks to the Mars Trace Gas Orbiter's unique orbit, it allowed the scientists to see the same region under different illumination conditions and angles, thereby allowing them to disentangle particle size and composition, which is essential for recreating the correct dust size in the laboratory. And data from NASA's Mars Reconnaissance Orbiter, together with ground-based measurements from NASA's Mars rovers Curiosity, Pathfinder and Opportunity, also help make the case for ferrihydrites. This is SpaceTime. Still to come, NASA's Europa Clipper has successfully completed a close gravity assist flyby of the red planet Mars as it continues its journey to the solar system's largest planet, Jupiter. And later in the science report, new research has found that just an hour spent in front of screens can increase your child's risk of developing myopia. All that and more still to come on SpaceTime. NASA's Europa Clipper mission has successfully completed its close gravity assist flyby of the red planet Mars as it continues its journey towards the solar system's biggest planet, Jupiter. The spacecraft streaked just 884 kilometres above the Martian surface, travelling at some 24.5 kilometres per second and using the planet's gravity to slingshot itself on the next critical leg of its long journey to the Jovian system. The maneuver changed the probe's trajectory and speed, and also offered mission managers an opportunity to test Clipper's radar instrument and thermal imager. A day prior to closest approach, mission managers began calibrating the thermal imager, resulting in a multicoloured image of the red planet, which will be sent to Earth in the next few months and processed. And during its close approach, they used the probe's radar to perform a test of its operations, the first time all the radar's components have been tested together. See, the radar antennas are so massive and the wavelength they produce is so long that it simply wasn't possible for engineers to test them before launch. As the spacecraft left Mars, its velocity slowed slightly to 22.5 kilometers per second. But the maneuver set Europa Clipper up for its second gravity assist, a close flyby encounter with the Earth slated for December 2026. That'll increase its velocity again, sending it to the outer solar system and its encounter with Jupiter and its icy moon Europa in April 2030. Europa Clipper launched from the Kennedy Space Center in Florida on October the 14th last year aboard a SpaceX Falcon Heavy rocket, embarking on a 2.9 billion kilometer journey to Jupiter, which is 5 times further away from the Sun than the Earth. Without the gravity assists from Mars and Earth, the 6,000 kilogram spacecraft would require additional propellant, which adds weight and cost, or alternatively, it would have needed to take a much longer, more circuitous route. Mission managers sent the spacecraft on an initial trajectory which left some buffer around Mars so that if anything went wrong in the weeks after launch, Europa Clipper wouldn't risk impacting the red planet. They then used the spacecraft's engines to veer closer to Mars in what are called trajectory correction maneuvers, or TCMs. Mission controllers performed 3 TCMs to set the stage for the Mars gravity assist, one in early November, another in late January, and the third back on February the 14th. They'll conduct another TCM around the middle of this month in order to ensure the spacecraft's on track, and are likely to conduct additional ones, upwards of 200 throughout the mission, which is likely to last until 2034. This report from NASA TV.
Everywhere on Earth that there's water, there's life. We have several ocean worlds in our solar system. And by exploring Europa, we're getting a taste of what these ocean worlds are like.
Europa is one of the moons of Jupiter. It's about the same size as our own moon, a little bit smaller, but it's so much different. It's an ice world.
Europa probably has beneath its icy surface a global ocean of water.
We think there are thermal vents in this vast subsurface ocean. There may be primitive organisms there, similar to the original primitive organisms on Earth from which we all evolved.
When we first discovered hydrothermal vents on our seafloors on the Earth, we also discovered life. There was no sunlight that was penetrating down that deep, but yet there was life living there.
On Europa, we're not looking for life itself, we're just looking for an environment in which life could thrive.
I just love Europa's surface. I think it's one of the most complex surfaces in our solar system. Typically, when you look at another planetary surface, it's covered with craters, just like our moon.
There are very few, shockingly few impact craters. So that means something is going on to erase the craters, just like happens here on Earth, and on Earth we call that geology. One of the key questions right now that we have about Europa is whether or not there's plume activity.
Plumes are one way that you can definitely get ocean material to the surface. We really need a spacecraft in the system that's watching Europa to see when those plumes are happening, if they're happening.
The Europa Clipper mission will be the first in-depth exploration of an ocean world.
Europa Clipper is orbiting Jupiter, and it's performing 49 flybys of Europa. And the main reason it's doing that is to stay mostly outside of Jupiter's really intense radiation belts.
Each time we make a flyby, we turn on all of the instruments at once.
Most of us know about cameras because that's what our eyes see, but there is a whole slew of other instruments on board Europa Clipper that expands our vision.
We have 4 different instruments that we're really using to take images of Europa's surface. We have the visible wavelength, the near-infrared, the far-infrared, and the UV, the ultraviolet.
We're hoping to see evidence of change, new cracks, new surface colors that indicate different materials maybe have moved around or come up from the subsurface.
We have an instrument that can sniff the very thin atmosphere, the gases, and determine the composition with extreme precision. We're looking for signs of organics at Europa. Are there materials that contain carbon and hydrogen and oxygen and nitrogen? And we have another instrument that can tell us the composition of dust particles. We're pretty sure there are salts on Europa's surface, and those salts may have come out of the ocean. We want to understand what are those salts.
We have a magnetometer and a plasma instrument that are going to be studying that magnetosphere environment that Europa is sitting in and Jupiter's magnetosphere environment.
The magnetic field of Europa, in turn, can tell us about the properties of the ocean. How thick is it, and how salty is it?
And then we have this novel ice-penetrating radar that will try to get below the ice shell.
Last but not least, we have a gravity experiment using the communication system of the spacecraft. And from that, we can get essentially a map of the gravity field.
We can get the shape, understand what's underneath, maybe even get some information on the depth of the ocean. It's really a sophisticated payload.
So there really has not been a mission like Europa Clipper. The pictures that we are going to get back are going to be just fantastic.
The legacy of Europa Clipper will be just a treasure trove of knowledge about this world.
Just to find an environment that is similar to the one from which life arose on Earth would really be groundbreaking. It would be awesome.
I have no idea what we are going to detect beneath Europa's icy surface, but all I know is it's going to be wonderful.
We do this work of exploration for the next generation. We don't know if Earth is the only place that life got started, or if it's really common. And a really important way to get at that is to understand, is there life elsewhere in our solar system?
And in that report from NASA TV, we heard from Europa Clipper project scientist Robert Pappalardo, Europa Clipper deputy project scientist Bonnie Baratti, Europa Clipper staff scientist Kate Croft from the Johns Hopkins Applied Physics Laboratory, Europa Clipper staff scientist Erin Leonard, and Europa Clipper investigative scientist Sean Brooks. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that the world's strongest ocean current, the Antarctic circumpolar current, is projected to slow down, and that slowdown could completely change the dynamics of the Great Southern Ocean, throwing off weather patterns and changing life for fish and other animals. More than 4 times stronger than the Gulf Stream, the Antarctic circumpolar current plays a huge role in the global climate system. But now new Australian research is suggesting that under future climate scenarios, the strength of the current is likely to decline by around 20% by 2050 in response to Antarctic ice melt. The study, reported in the journal Environmental Research Letters, shows that as ice sheets in the Antarctic continue to melt, it creates an influx of fresh water in the ocean, which changes the water density and consequently circulation patterns. The research follows previous work, which shows that the same processes are also slowing the circulation of nearby deep ocean water, known as Antarctic bottom water. New research suggests that it might be time to reassess the current treatment of prostate cancer. A report in the British Medical Journal looked at different kinds of mutations in BRCA1 and 2, ATM, and CDK12 genes among some 450 prostate cancer patients. BRCA2 was identified as the predominant gene in prostate cancer progression, being involved in 11% of metastatic cases. That's where the cancer travels elsewhere in the body. On the other hand, BRCA1 variants didn't seem to be a major contributor to disease initiation or progression. Currently, BRCA1 and BRCA2 are often grouped together when researching and treating prostate cancer. But the researchers say if their results are confirmed with further research, it might be time to start treating and analysing these mutations somewhat differently. Well, it looks like that old person's tale that too much screen time can give you square eyes may contain a grain of truth. New research has found that an hour spent in front of screens increases a kid's risk of myopia or short-sightedness by 21%. The findings, reported in the Journal of the American Medical Association, claims that scientists pulled together 45 studies looking at over 300,000 kids. They found the risk of myopia increased significantly between 1 and 4 hours of daily screen time and then rose more gradually after 4 hours. Amazon has unveiled its new generative AI-infused Alexa. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Amazon has completely revamped its Alexa assistant. Now, it's going to launch in the next few weeks in the US and in waves in the coming months in the rest of the world. And it will start with the Echo Show 8, 10, 15, and 21. And it's called Alexa Plus. They're saying it's the next generation of Alexa. So think of it as Alexa 2.0. They say she is smarter, more conversational, more capable. It engages in natural, flowing conversations that feel genuine, making it more similar to ChatGPT. That's the gold standard. And it understands context and meaning, creating seamless interactions with no precise Alexa language. So, it's free-flowing. It's personalized, so it learns from you, and obviously the more you use it, the more personalized it gets. It understands everything from your favorite entertainment to your family's dietary preferences, allergies, and weekly traditions. You can get things done. It can handle things for you like date planning or gift shopping or travel arrangements, study help. So this is the long-awaited upgrade. And there are 600 million Alexa devices now there in the marketplace that can take advantage of this. So this will come pretty soon. And finally, the promise of the artificial assistants, Siri and Alexa and Google Assistant, that we sort of thought was being launched a decade ago. Well, a decade later, it's finally happening.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.